Welcome to the 8th lecture on digital simulation. In this video, we will go through Sparse Tableau Approach. So far, we had studied modified nodal analysis, and in modified nodal analysis, for solving a given circuit, we will treat node voltages except the reference node voltage and currents through voltage sources as variables. Currents through voltage sources. So these quantities were the variables in modified nodal analysis. All node voltages except the reference node voltage and all currents through voltage sources. Whereas in Sparse Tableau approach, we will treat all branch currents, all branch voltages, and all node voltages except a reference node voltage as variables. So if there are n nodes, if there are n plus 1 nodes in a circuit including the reference node, then apart from the reference node there are n nodes, so we can have n node voltages. And if there are b branches in the network, then we can have b branch currents and b branch voltages. So there are b branch currents, b branch voltages, and n number of node voltages. So there will be n plus 2b variables in Sparse Tableau approach. So we have to formulate n plus 2b equations to solve the system. So from where we will get the n plus 2b equations? There will be three sets of equations. One set of equation we will get from KCL by applying KCL at all these n nodes. Apart from the reference node, there are n nodes, and at each of these nodes we can apply Kirchhoff's current law and we will be able to write n equations. Then the second set of equations we will get from the branch voltage definitions. Branch voltage definitions. I will explain what is this in the coming slides. Branch voltage definitions, BVD. So for each branch we can define the branch voltage in terms of the node voltages in the network. So we will get a branch voltage definition for one branch. So there are B branches, so we will get B branch voltage definitions. Then branch constitutive equations or branch constitutive relations. For each branch, based on the nature of the element in that branch, we can write branch constitutive equations. And since there are B branches, we can formulate B such equations. So total number of equations is now n plus B plus B or n plus 2B. So there will be n plus 2B equations in this Sparse Tableau approach. So if you have a circuit with n plus 1 nodes and B branches, then there will be n plus 2B variables and n plus 2B equations in this STA technique. Now let us illustrate this approach with the help of an example. So a circuit diagram is shown here. We have to write the Sparse Tableau approach equations. So let us identify the variables first. So node voltages are variables. So this is a node in the circuit. So this node voltage we can label as V1. So this is another node. We can label this voltage as capital V2. So node voltages are V1 and V2. And this is our reference node. So reference node potential is 0 volt. So only two nodes are there, V1 and V2, apart from the reference node. Then we have to mark the branch currents, all branch currents. So I have marked it in this figure. All branch voltage I have marked here. So U1 is the branch 1 voltage with this polarity. U2 is branch 2 voltage. U3 is already marked in the figure in the question. Then U4 is this branch voltage. Okay, so all the four branch voltages are marked in this figure. Now branch currents. We will mark branch currents. So branch currents are I1 is the branch current flowing through branch 1. So the direction is taken such that it enters the positive terminal of this branch voltage definition or branch voltage U1. Then the second branch current is I2 and you can see that it enters the plus terminal of U2. Then third branch current is I3. Here also it enters the plus terminal. And the fourth branch current is I4. Okay, so branch currents are also marked. So now we can write the variable metrics. So the variables are branch currents I1, I2, I3, I4 and branch voltages U1, U2, U3 and U4. Then branch currents and branch voltage, then node voltage. Node voltages are V1 and V2. So how many variables are there? 4 branch currents, 4 branch voltages and 2 node voltages. So there are 8 variables. 4 branch currents, then 4 branch voltages, 2 node voltages. So now we have to formulate 10 equations in order to solve the system. So let us write the equations one by one. So first we can formulate the KCL equations. So let me copy the previous diagram. So at node 1 we can write the KCL. At node 1 I1 is flowing out, so I1 plus I2 is also flowing out, so I2, then I4 is flowing out from node 1. So sum of all the outgoing currents I1 plus I2 plus I4 will be equal to 0. That is for node 1. Then for node 2 also we can write the KCL. For node 2 I3 is flowing out, so plus I3, I2 is coming in, so minus I2, then I4 is also coming in, so minus I4 equal to 0. So it is minus I2 plus I3 minus I4 equal to 0. So we got 2 equations from KCL. Now we can write the branch voltage definitions. BVD, branch voltage definitions. So we have 4 branches, so we need to write 4 branch voltage definitions. First branch voltage is U1. So U1 is actually equal to node 1 voltage V1 minus reference node voltage 0. So it is actually V1 minus 0. Branch 1 is connected between node 1 and reference node. So node 1 voltage minus reference node voltage is branch 1 voltage. Node 1 voltage V1, reference node voltage 0. So U1 is simply equal to V1. So we can write one equation as U1 minus V1 equal to 0. So this will be our third equation. So the second branch voltage is U2. And you can see U2 is connected between node 1 and node 2. So it will be V1 minus V2. So the branch voltage definition equation is U2 minus V1 plus V2 equal to 0. So this is fourth equation. Then coming to third branch U3. U3 is equal to V2 because third branch is between node 2 and the reference node. So it is simply V2. So U3 minus V2 equal to 0. That is our fifth equation. And the last branch U4 is equal to alpha U3. And alpha is nothing but 0.5. So U4 minus 0.5 U3 equal to 0. This is our sixth equation. So we got 6 equations. Now we need 4 more equations. So KCL equations and branch voltage definitions are completed. Now we have to write the branch constitutive equations. Let me take a new page. The branch constitutive equations we can write. So the branch 1 voltage U1 is 10 volt because in branch 1, the element is a voltage source. So its voltage directly specified is 10. So U1 equal to 10 is our seventh equation. Then branch 2 voltage is U2, and branch 2, if you look at branch 2, it is a resistance. So U2 is simply 5 times I2, 5 into I2 by Ohm's law. U2 is a voltage across 5 ohm. It is equal to 5 ohm multiplied by the current flowing through it, 5 into I2. So this can be written as minus 5I2 plus U2 equal to 0. This is our eighth equation. Then third branch voltage U3 is nothing but 2I3, 2 into current through the 2 ohm. So this is minus 2I3 plus U3 equal to 0. So it is ninth equation. And coming to the last one, U4 is equal to, we cannot directly write expression for U4 because this is actually a current source. So we can write another branch constitutive equation. Based on the nature of the element, we have to write an equation. So this current is given in the question, alpha U3. So that current is nothing but I4. That branch current is I4, and this, since it is a voltage controlled current source, magnitude is alpha U3. So I4 equal to alpha U3 is the equation. Alpha is 0.5. So I4 equal to 0.5 U3, or I4 minus 0.5 U3 equal to 0 is our 10th equation. And if you can arrange these 10 equations in matrix form, that will give you the STA matrix. So let us try to write that also. So it will be a 10 by 10 matrix multiplied by the column vector. Column vector consists of variables I1, I2, I3, I4, branch currents, then branch voltage U1, U2, U3, U4, then node voltage V1 and V2. So there are 10 equations. Right hand, there will be right hand side column vector. So now let us fill the coefficients. So the first equation was from KCL, I1 plus I2 plus I4 equal to 0. I1 into 1 plus I2 into 1 plus 0 I3 plus 1 into I4 equal to 0. All other terms are zeros. So I1, I2, I3, I4, U1, U2, U3, U4, V1, V2. And the second equation is minus I2 plus I3 minus I4 equal to 0. Minus I2 plus I3 minus I4 equal to 0. Okay. Then the third equation is from KCL. Sorry, from branch voltage definition, that is U1 minus V1 equal to 0. U1 minus V1 equal to 0. Minus V1 equal to 0. Then fourth equation is U2 minus V1 plus V2 equal to 0. U2 minus V1 plus V2 equal to 0. So I have completed 4 equations. Like that, you can write the remaining 6 equations in this matrix. So you will get a 10 by 10 matrix here. And here it is a 10 by 1 column vector. So that will complete the sparse tableau equations for this particular network. So let us do one more example to reinforce this concept. So here another diagram is circuit diagram is given. So for doing sparse tableau approach, first you have to identify the nodes. So this is node 1, this is node 2, this is node 3, and this is node 4, and this one is our reference node. So there are 4 nodes. Apart from the reference node, there are 4 nodes. So 4 KCL equations will be there and 4 node voltage variables. Then how many branches are there? So this is branch 1, branch 2, branch 3, branch 4, branch 5, branch 6. 6 branches are there. 6 branches. So 6 branch currents will be there and 6 branch voltages. So 6 plus 6 plus this 4. So there are 16 variables and 16 equations. So in order to write the 16 equations, first you have to mark the variables in the circuit. So I have marked node 1 voltage as V1 here, node 2 voltage as V2, node 3 voltage as V3, node 4 voltage as V4. Then I have to mark the branch voltages. Branch voltages are marked here. Branch 1 voltage U1, branch 2 voltage U2, branch 3 voltage U3, branch 4 voltage U4, this is U5, this is U6. Then I have to mark the currents. Then current flowing through branch 1 is I1, current flowing through branch 2 is I2. So I will take the direction of branch current such that it enters the positive terminal of this branch voltage definition. I3 is entering here at this plus terminal. Branch 4 current I4 is entering this plus terminal. Then here I5 is entering the plus of U5. Then this is I6. So we have marked all the branch currents and branch voltages and node voltages. So from this you can write the KCL equations. Then branch voltage definitions. Then third one, branch constitutive equations. So let us write it one by one. In KCL, if you write KCL at node 1, it is simply I1 minus I2 equal to 0. I1 is flowing out from node 1, I2 is coming in, so I1 minus I2 is 0. Then at node 2, the KCL is I2 plus I3, both are flowing out equal to 0. Then at node 3, I4 plus I6 minus I3 equal to 0. Then node 4, I5 is flowing out, I4 is coming in, I5 minus I4 equal to 0. So we got 4 equations. There are 4 nodes, 1, 2, 3, 4. So 4 KCL equations we got. Then branch voltage definitions. Branch voltage definition U1. What is U1? U1 is V1 minus 0. V1 minus 0, that is V1. U2 is V2 minus V1. Then U3 is V2 minus V3. Then U4 is between 3 and 4, V3 minus V4. Then U5 is this voltage, that is same as V4 minus 0, or it is equal to V4. Then last one, U6 is V3 minus 0. So we got 6 branch voltage definitions. From this you will get 6 equations. Then last one is branch constitutive equations. Branch constitutive equations we can write for each branch. For branch 1, what is a branch constitutive equations? If you look at branch 1, U1 is equal to the resistance into I1. So that resistance value is required. Suppose this is R1, R2 and R3. Then U1 is I1 R1, or minus I1 R1 plus U1 equal to 0. So this will be the branch constitutive equation for this branch. Similarly for second branch, what is a branch constitutive equation? For second branch it is U2 is a branch voltage, that is equal to alpha U4. So U2 minus alpha U4 equal to 0. Value of alpha will be given. So that is a branch constitutive equation for second branch. And coming to third branch, it is U3 equal to I3 into R2, or U3 minus I3 R2 equal to 0. That is the branch constitutive equation for third branch. And coming to fourth branch, again U4 is equal to this current I4 into R3. So U4 minus I4 R3 equal to 0. It's our fourth branch constitutive equation. Then coming to fifth branch, U5 is actually not defined because it is a current source. So you can write another expression. What is I5? I5 will be equal to I0 with a negative sign because I5 is flowing downwards, I0 is marked upwards. So I5 equal to minus I0 will be the branch constitutive relation for fifth branch. Then coming to sixth branch, U6 is nothing but V0. U6 is equal to V0. So we got 1, 2, 3, 4, 5 and 6. 6 branch constitutive relations. So adding this to 6 branch voltage definitions and 4 KCL equations, we will get 16 equations. So that is how we can formulate the equations in Sparse Tableau approach. So take a network and try to write the Sparse Tableau equations to familiarize this again. Thank you. We will continue in the next video.